This question asks you to identify correct statements regarding different kernel functions used in Gaussian process regression within the scikit-learn library. Let's dive into the exciting world of kernels. We'll examine properties of several kernels and how they combine. I'm going to explain each option, and you can then pick the correct answers. This statement says the radial basis function, RBF, kernel's output only depends on the distance between input data points, making it stationary. This is true. The RBF kernel uses a Gaussian function that measures distance. Think of it like this. The closer two points are, the more similar they are considered. The dot product kernel is best suited for data where the relationship between points is strongly linked to their inner dot product. Essentially, how much they align. This is also a correct statement. This statement is also correct. In scikit-learn, adding kernels using the plus operator results in a new, valid kernel, whose output is simply the sum of the outputs of the individual kernels. It's a straightforward way to combine kernel functions. I will tell you that this is a false statement. While the modern kernel approaches the RBF kernel as its parameter new goes to infinity, they are different for new equals 0.5. They have distinct mathematical formulas. I'll explain the flow of this multiple choice question. First, you'll encounter a problem statement introducing scikit-learn's Gaussian process regression, GPR, and its various kernels. Then, you'll analyze each statement carefully, checking if it accurately describes the properties of those kernels within scikit-learn. To answer correctly, you must recall the definitions and properties of the kernels, RBF, dot product, mattern, and understand how they combine. Finally, evaluate each statement's accuracy. It's a test of your knowledge of Gaussian processes. This is a multiple-choice question about scikit-learn's Gaussian process regression, GPR, kernels. I'll guide you through understanding the different kernels and how to choose the correct answer. This is the core question. I'll evaluate statements A, B, C, and D based on my knowledge of scikit-learn's GPR kernels and their properties. Statement A says the radial basis function, RBF, kernel is stationary. This means its output depends only on the distance between data points, not their absolute location. I'll check this statement against my knowledge of RBF kernels. Statement B focuses on the dot product kernel. This kernel is useful when the relationship between data points is strongly linked to their inner product, a measure of similarity. I need to verify this based on the definition of the dot product kernel. Statement C describes kernel addition. It claims that adding kernels using plus always results in a valid kernel. I need to confirm whether this is true for all kernel combinations within the framework of scikit-learn. Statement D compares the mattern and RBF kernels. It states that a mattern kernel with a specific new value, 0.5, is the same as an RBF kernel. This needs careful consideration, as the mattern and RBF kernels have distinct mathematical formulations. I'll verify this equivalence claim. This section introduces the core topic, Gaussian process regression, GPR, kernels within the scikit-learn library. This is a powerful machine learning technique, and I need to be comfortable with its fundamental concepts to answer the question properly. This quiz focuses on Gaussian process regression, GPR, which uses kernels within the scikit-learn library in Python. We'll explore different kernel types and their properties. Think of kernels as functions that define how data points relate to each other. They're crucial for building a GPR model. This is a multiple-choice question that tests your understanding of scikit-learn's GPR kernels. I'll guide you through each option. Get ready to show your knowledge. The radial basis function, RBF, kernel is a stationary kernel. That means it only cares about the distance between two data points, not their absolute locations. Imagine the distance as a measure of similarity. The closer the points, the more similar, and the RBF kernel reflects that. The dot product kernel is perfect when the relationship between data points hinges on their inner product. Think of it as a measure of how much they align. It's like seeing how similar two vectors point in the same direction. You can combine kernels using the plus sign. Adding kernels creates a new kernel that's simply the sum of individual kernels' outputs. It's a valid operation that always results in another proper kernel. The Mattern kernel is a versatile kernel with a parameter called new. While it does approach the RBF kernel as new gets very large, a new of 0.5 is not the same as an RBF kernel. They have different mathematical forms. Think of them as having different shapes. We're going to pick the correct statements about different kernels used in Gaussian process regression, GPR, using scikit-learn. Think of kernels as ways to measure similarity between data points. GPR uses these similarities to make predictions. This is a multiple-choice question. I need to evaluate each statement carefully to find the ones which accurately describe how these kernels work in scikit-learn. The radial basis function, RBF, kernel is a popular choice. It's called stationary because its output only depends on the distance between two data points. Their actual location doesn't matter. The further apart the points are, the less similar they are considered. The dot product kernel focuses on the inner product, a mathematical operation, of data points. If the inner product is high, it implies high similarity. I'll choose this if data point relationships are best represented by their inner product. This is great news. You can combine kernels simply by adding them. The resulting kernel's output will just be the sum of the individual kernel's outputs. This is a valid method within scikit-learn. The Mattern kernel is another type, and it's a bit more flexible. However, a Mattern kernel with a new parameter of 0.5 is not the same as an RBF kernel. They look different mathematically, so this statement is incorrect. This question focuses on Gaussian process regression, GPR, a powerful machine learning technique. I'll explain different kernels used within scikit-learn's GPR implementation. We'll be exploring multiple-choice statements that test your understanding of kernels and their properties in scikit-learn's GPR. This is the core question. I will evaluate the accuracy of 4 statements, each describing properties of different kernel functions within scikit-learn's Gaussian process regression. Statement A claims that the radial basis function, RBF, kernel is stationary. A stationary kernel's output depends only on the distance between input points, not their absolute location. This is indeed true for the RBF kernel. Statement B suggests that the dot product kernel works well when data relationships are mainly defined by the inner product of input vectors. This is correct. The dot product kernel explicitly uses the inner product in its calculation. Statement C says adding kernels using the plus operator in scikit-learn creates a valid new kernel that's the sum of the individual kernel's outputs. This is absolutely true. Statement D incorrectly claims that a Mattern kernel with a new parameter of 0.5 is identical to an RBF kernel. Although they become similar as new approaches infinity, they are not equivalent. At new equals 0.5. They have different mathematical formulations. These are the options provided to answer the multiple-choice question, testing knowledge of kernels in Gaussian process regression. This question tests your understanding of kernels in Gaussian process regression, a machine learning technique used for regression tasks. We'll explore several kernel types and how they behave. The radial basis function, RBF, kernel is stationary. This means its output only depends on the distance between two data points. If you move the points, but maintain the distance between them, the RBF kernel's output will remain the same. Think of it like this. The kernel only cares about how far apart 2 points are, not where they are exactly located in space. This is a very useful property. The dot product kernel works well when the relationship between data points depends on how similar they are in terms of their inner product. Think of it as a measure of how much they point in the same direction. I find this kernel especially useful when data exhibits linear relationships. You can combine kernels by adding them together using the plus operator. This is a valid operation. The resulting kernel simply outputs the sum of what each individual kernel would output. It's like having 2 different ways to look at the relationship between points, and combining both perspectives to get a better overall view. The Mattern kernel with new equals 0.5 is not the same as an RBF kernel. While they are related, they have distinct mathematical formulas, leading to different behaviors. The Mattern kernel is more flexible and can represent a range of smoothness levels via its new parameter. This instruction tells you to select all statements that are correct. Some might be false. This is the core question. You need to assess the accuracy of several statements about Gaussian process regression, GPR, kernels within the scikit-learn library. This sets the stage for the multiple-choice question. You need to evaluate several statements' accuracy regarding the behavior of different kernels within the context of scikit-learn's GPR implementation. This question focuses on understanding different kernel functions in Gaussian process regression, GPR, a machine learning method. We'll explore how these kernels work and how we can combine them. Think of kernels as the tools we use to model the relationships between data points in our dataset. Each tool has unique capabilities. This is a multiple-choice question that tests my knowledge of the different kernel types available within scikit-learn's _Gaussian_process. Kernels module. I need to select all the correct statements. This instruction reminds me that multiple options might be correct. I need to carefully consider each statement individually. The radial basis function, RBF, kernel is a common choice for GPR. I should recall the definition of stationary here. A stationary kernel means the relationship between two data points depends only on their distance apart, not on their location. I'll think about whether this applies to the RBF kernel. The dot product kernel focuses on the inner product, a mathematical operation, of the data points. I need to see if that matches the description given. This statement deals with kernel combination. I need to verify whether adding kernels using the plus operator will always result in a valid kernel, which is a type of kernel used in the Gaussian process regression model. The Mattern kernel is another popular choice. The parameter, nu, affects its smoothness. I need to check if a specific value of nu, 0.5 in this case, makes it identical to the RBF kernel. Let's find out.